Hello everyone, this is Vani working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. In this video, we are going to learn about amplitude shift keying, which is one of the fundamental digital modulation scheme. So, ASK, amplitude shift keying, which is also called as on-off keying modulation technique. It is a form of digital bandpass modulation technique in which the amplitude of the analog sinusoidal carrier signal is varied to represent the input binary data. So input data is a digital data, carrier is analog, and the amplitude of carrier is varied according to the input binary data, and at the same time only amplitude is varying, the frequency and phase of the carrier signal remains unchanged. So that is the unique feature of amplitude shift keying, which is also called as on-off keying. We will understand why it is called as on-off keying in the next slides. Now let us consider a digital baseband signal, which is called as modulating signal, which is represented by unipolar non-return to zero. The meaning is the voltage is 1 for binary 1 and 0 for binary symbol 0 for the entire duration TB in the form of on-off signal. Right? So when it is on, it is 1, and when it is off, it is 0. That's why this modulation is also called as on-off key. Now, if I take the representation as a mathematical expression, then the carrier signal is represented by sine omega ct, or omega c we can replace by 2 pi fc, where fc is the frequency in hertz. So as per the definition of ASK, when the amplitude of the carrier signal is varied in proportion to the modulating signal Vm of t, my carrier signal is varied, which is analog with respect to Vm of t, then the ASK output, or we call it as modulated signal, can be written as Vm of t, which is the amplitude, sine 2 pi fct. So what is the value of VSK? If we consider, it is equal to sine of 2 pi fct for binary 1, and it is 0 for 0. So this is my modulated signal where my carrier is varied in accordance with my message signal. So this can be better understood by taking an example. So using this definition, let us take a waveform for the binary data 10110101111. So it's a binary data sequence, right? So we are drawing it for non-return to 0. We know that it is existing for the entire duration. It is 1, then for 0 it is 0, for 1 we are taking this value, and again continued by 1, 0, 1, 0, 1, 1, 1, right? So my carrier signal is analog signal, which is represented by sine of 2 pi fct. So this is message signal, this is carrier signal. Now as per the definition of ASK, carrier signal is varied in accordance with the input binary data. So whenever the input binary data is 1, carrier is available. When it is 0, carrier is not available. Again for 1, if we see correspondingly, this for both ones it is available. For 0, it is not available. For 1, it is existing. For 0, it is 0. For all triple 1, the carrier signal is same as the input. That's why this waveform is called as on-off, on-off, on-off keying. It is the simplest method of digital modulation scheme. Now, if we take other two types, other two fundamental types, it is phase shift keying and frequency shift keying. So in case of amplitude, we have seen that the carrier signal is a analog sinusoidal signal, which is varying with respect to the input digital data. So here it is 0 means it is 0, and 1 means carrier signal is available. For phase shift keying, there will be a phase shift when the signal is getting, the input data is changing from 0 to 1 and 1 to 0. If we see here correspondingly, When it is changing from 0 to 1, there is a phase shift. For 1, it is same as the carrier signal. For 0, again it is changing. For 1, again it is changing. For 0, again it is changing. Next time when 1 appears, it is changing. So whenever there is a transition, the phase shift is happening. It indicates that the message is 0 and 1. And finally, for FSK, if we see, for 0, the frequency is low, and for 1, the frequency is high. So in this way, the message is communicated by using FSK. When we receive this part, it is 0. When we receive this part, it is 1. So all three, ASK, PSK and FSK, are binary modulation schemes which apply the variation in amplitude, phase and frequency. That is, carrier is varying its amplitude, phase and frequency in accordance with the message signal, which is binary digital data. Now, if we just understand how the ASK modulator and detector are operating, so we just have a fundamental balance modulator where, as we have seen in the previous slide, our digital data is input, carrier signal is analog signal, which is sine 2 pi FCT. Both are modulated. Binary ASK signal is generated, which is passed through band pass filter, and the output is band limited ASK signal. This is actually modulator. The operation is taking place at the transmitter side. Now, if we see the detector side, right, as we are seeing coherent type, the same carrier signal will be used here. The input is received binary ASK signal, right? Both are again demodulated, where the decision device is comparing with the threshold. If the input received signal is above the threshold, then it is taken as 1. If the received signal is below the threshold, it is taken as 0. So whatever input signal was given, the same is generated at the output. So it is a simple model. Now, if we go for non-coherent binary ASK detector method, the only difference we can see here is we don't use any phase lock or we don't use any carrier modulator here. Right? The received signal is just band pass filter. The envelope is detected using a rectifier plus low pass filter combination, and the same as decision device, where the received signal is compared with the threshold. If it is greater than threshold, 1 is the output. If it is less than threshold, 0 is the output. So this is very simple binary ASK detector based on non-coherent. At the same time, the error probability of this method is higher compared to coherent method. So in order to understand the behavior or the signal representation of ASK, constellation diagram is used. So it displays the signal as a two-dimensional XY plane scatter diagram in the complex plane. We have in phase and quadrature phase, that's why it is called as complex plane at symbol sampling instant. Let us see what is the constellation diagram of ASK. So normally, as I told, in the complex plane, we have in phase component and quadrature phase component, right? And this part is representing the amplitude of I component. This part is representing the amplitude of Q component. And this represents the angle, and this is the resultant amplitude. In case of ASK, we have only two options, either 0 or 1. In simple form, we are seeing this instead of taking EB values, just to understand, right? So we have two possibilities, either 0 or 1. So the constellation diagram is shown where I is in phase component and Q is quadrature phase component. So in this video, we have just defined what is ASK. We understood why it is called as on-off keying. We have seen the mathematical expression for ASK, followed by transmission and reception using the simple model of both coherent and non-coherent, and finally constellation diagram. Thank you.